Today we'll talk about a linear equation. What does it mean, a linear? Raise your hand. Linear. How do you understand it? Linear. Why do we call this equation linear? Vlad, you can talk.
I forgot.
You're wasting these precious seconds of this video. Max, what is linear? What does this word mean, linear? Yeah. Does this tell you anything? It's like high rank, okay? Well, but does this word tell you anything?
Right.
It's a line. Yes, if I wanted to represent that equation graphically, it would actually fall into a line right here, somewhere, linear. Well, are there other equations besides linear?
Yeah.
What are other equations there? What are they? Do you know? Like, you know, how would they look? Linear. What if I had something like this? Is this linear?
Parabola.
Oh, no, I like it. How do you know that?
X squared.
There you go. You see the difference? What is the exponent of this x? What is the exponent of this x? Very nice, Jasmine. 1. If you don't see anything, that doesn't mean it ain't there. It's a 1. It's an invisible 1. You see this guy? That makes it a quadratic equation. Everything I write, you write, okay? You keep staring at my beauty. Right equation. And as Naomi said, it would look like this, you know, or like that, you know, or like this. And then we also have equations that can be represented like this, you know, things like that. But we will study that in January or February, okay? All right, moving on. So this is what we are dealing with, a linear equation. What you studied before is you look at operations, addition, addition, addition. You see, it's not just one operation, it's addition, addition, addition. How are you gonna solve it? Subtraction, subtraction, subtraction. So are you going to subtract 23 and then subtract 37? You know, okay, add 2x, subtract 2x. You know, that's just too many steps that will look just too busy on the page. Remember the step 1 that I taught you. Move what?
Variables.
All variables. Very nice. Where?
To the left.
Nope.
To the right.
Nope.
To one side.
To one side.
David said that.
To one side. And why does it matter? To one side, and I'm not specifying left or right.
So it's easy.
Yeah, but not. Why don't I just say to the left or to the right?
Because maybe there will be variables on the right.
Exactly. Maybe there will be variables on the right that are negative, and I want to move them to the left, make them positive. So it's easier for me to work with them, right? Or what if I have all the variables on the left, like 5 of them, and 1 on the right? Of course, I'm going to move the 1 on the right to the left, right? I mean, you're inspecting your equation. If you see, okay, see, I already have 9x and 2x here. This guy will go where? To the left, because it's just easier. I already have some variables, more than 1 on the left, right? So it really doesn't matter which side. Melanie, concentrate. Okay, so move all the variables to one side and numbers
To another.
to another. So we are going to perform that step. Remember, your equation looks like a Christmas tree upside down. So you see the equation sign here? I hope you wrote all that down. So I'm gonna start here, you know. So it looks like a tree upside down. So 9x, it was on the left, it stays on the left, so nothing changes. Are you eating in my class? Plus 2x, I'm just moving it closer. It's not moving across the equal sign, right? It's not going anywhere. It's on the same, it's kind of like switching rooms with his sibling, you know, but they're still on the same floor, right? 2x, and then I have a positive 4x. It moves. It flies across the equal sign. What will happen to it, Nadine?
Can become opposite.
it will have an opposite sign. So it was a 4x, and now it will become negative 4x. Some of you are still moving those variables however you want. That doesn't work for me. You have to be aware of the signs. What do I have on the right, Jasmine?
You do 37.
37, it was on the right. It was positive. Is it moving?
No.
No. Can I move it closer to the equal sign?
Yeah.
Of course, you know, it's the same floor, you know, we're just kind of moving from kitchen to the bedroom or whatever, to the living room. 37, and I have to drag 23 to the right side. What will happen to it?
It will be opposite.
It will become opposite. Thank you. Okay. Equal sign, again. Combine like terms. You see they're all like. Naomi, combine these guys.
7x. Well, 9 plus 2 is 11. Minus 4 is 7.
Nice. Good job. Who can combine these guys? The numbers. 14, right? You see multiplication? That means I'll be solving it by division. Dividing by 7, dividing by 7. Or the other way around, multiple product. Octavian, to solve for a multiple, you do what? Moment of truth, silence. Because he's about to receive a tattoo with a Sharpie with this rule as his life motto. The rule that I can never remember. To solve for a multiple, I do what? You can continue, Kareem. The rule. Jump in at any time.
To solve for multiple, I divide product by all of them.
Exactly. Beginning tomorrow, you say it like there's no tomorrow, okay? Like that's your only chance to say it. You have to know this rule, otherwise I'll be writing it on your arm with a Sharpie. To solve for a multiple, I divide. See? Completely absent.
Divide product.
There you go. I divide product. You need to know what are you dividing, right? I divide product, multiple product. I divide product by all other multiples. What are other multiples? There's only one, 7, because I'm solving for x. So there's only one. Concentrate, focus. Spacing, space camp, space cadet. So this is how we get to our x equals 2. Does this make sense? Now it will be your turn. You can turn it off.